This evening we're going to work with circles. In particular, we're going to work with circumference and area circles. Just a little bit of vocabulary with circles. Again, you have what we call the center of the circle, but this line segment that goes from the center of the circle to the circle itself, if you're on the circle, that segment is referred to as the radius. Another word that's important is if you have a line segment that goes through the center of the circle, this line segment that goes through the center of the circle, that is referred to as a diameter. So those are two important words. Also pick up on that it takes two of the radii to equal a diameter. So we could say the diameter is equal to 2 times the radius, since it takes two of them. Some other things we'll pick up on is, one is the circumference of a circle. The circumference of a circle is actually a special formula. Actually, we have two formulas for the circumference of a circle. Again, the circumference of a circle is actually the distance around the circle. For what we call polygon shapes that have edges, we use the word perimeter. But for a circle, the distance around a circle is referred to as the circumference. So, the other word we have is the area of a circle. The area of the circle is how many squares are inside the circle. And notice that you really can't break the circle up into squares, so we're going to have to get some type of approximation, because this kind of has those rounded edges, and squares actually have those sharp edges. So that's going to be a little tricky. So what they've done over the years is they created a couple formulas that we can use. The circumference formula is going to be C is equal to pi times the diameter. Or sometimes it's referred to as C equals 2 times pi times the radius. So again, this symbol here is a Greek letter which is referred to as pi, pi. Sometimes in some textbooks it's approximately 3.14. So it's a rounded decimal number, but actually pi is really not considered a rational number. It really can't be expressed as a decimal number. So sometimes it's referred to as an irrational number because of its strangeness. On your calculators, there actually is a pi button on your calculator. On this calculator here, it's right above what we call the housetop key. There's actually the Greek symbol pi. If you hit that, if I turn the calculator on here, and if I hit that, it actually will put that Greek letter on the calculator, the symbol for pi. If I want to change it to decimal, there's this little double arrow button down here, which we call the toggle button. If I hit that, it'll change it to a strange number, but it's still rounded because the calculator can't give me the exact value of pi either, but it does give me a more accurate use of pi. So, let's start with this question here. Let's say it says, find the area of each. It says, use your calculator's value of pi, round your answer to the nearest 10th place. So, to find the area of a circle, we actually use this formula over here. Area equals pi times the radius squared. Just like simple interest, we're going to basically just replace the letter with the value that goes in for the letter. And to figure out what the area is, what we have to know is what the radius is. So if we know what the radius is, we can just replace R with what that letter is. So if I want to find the area of a circle, we write the formula A is equal to pi times the radius squared. And notice that in this problem they do give me the radius of 12 inches. So the area is going to equal then pi times 12 squared. Now at this point, I can stick this into the calculator. I can actually type the pi in there, and I can multiply by 12 squared. And the calculator actually gives me 144 pi. So it actually leaves the answer in terms of pi. It does actually change the pi to a number at this point. Now, if I want that answer to be converted over to a decimal, I still got to hit this little toggle button. And it gives me this 452.3893421. It gives me this big old decimal. But in our directions, the directions say round your answer to the nearest tenth. Well, we know the tenths place is that first place after the decimal. So I actually got to write this out 2 places past decimal. So the area is going to equal approximately then 452.38. And then, since it says round to the nearest tenth, I have to decide, is this going to be 452.3 or is this going to be 452.4? Well, since that 8's there, that tells me to round on up to the 4. So that's going to be 452 and 4/10. And since we're dealing with area, remember area is measured in square units, so this would be square inches. So we'd use that notation there, 452.4, and this notation here represents square inches. So let's look at example 2. I have to again find the area. Again, to find the area, I have to know the radius, and they do give me the radius as problem, so it's a straightforward substitution. So A equals pi r squared. A equals then pi times, and I can replace the r squared with 14 squared. So then from here I can use the calculator. I can type in pi times 14 squared, and that gives me 196 pi. But again, the directions say round to the nearest tenth. So I hit that little double arrow button. It changes it to then approximately 615.75. And since I'm rounding to the tenths place, that's going to be 615 and 8/10, because that 5 would round on up to the 8. And since we're doing centimeters, our area is going to be then in square centimeters. So we write it like that. So our answer is going to be 615 and 8/10 square centimeters. So those are some examples of how to find the area of a circle. Stay tuned.